I'll let you answer 1 and 2, and then I'll raise it up better so you can see 3 after you answer 1 and 2. Number 1 is not multiple choice. It has 4 parts. It's an A, B, C, D part. It says for each function, there's only going to be one of those, what is the output of the given input? So number 1, part A says use a 0. Go put a 0 in place of all those extras and see what your output would be. And part B, do it again with a negative 12. And part C, do it again with a 9. And part D, do it again with a 12. Number 2 is a yes or no. 3, we'll raise up higher when you're ready for 3. Just drinking some. There we go. Just a drinking some. Sure. Is to multiple choice. Yeah. I didn't read it well. I thought you were supposed to use 0 as your input. Oh, you're finding the f of 2, and one of those answers is the answers. I'm sorry. Less work, right? Did you lose your sheet? Or do you have your notebook with you too?
Yeah, that's our sheet.
Okay. We'll just hang on to this and we'll just attach this to the other so that you have copies. control here. Number 1. Yeah, there's f of x and then x's. Go find, it's read the f of 2. It just means go put a 2 in for that x and put a 2 in for that x. So the output of using a 2 would be negative 6 plus 6 makes 0. It's always nice when the first answer you come to is the right one. Is number 2 a function? Why, yes. That's right. You start with the input, and the same input can't go to 2 different outputs. So that is okay. Did any of them all go to the same thing? No, if everybody was going to a different place. All of these inputs all go to the same output, but you can't go the other way. Number 3, the vertical line test. Which one represents a function? Which one? It is B. It is B. B is the only one, when I draw a vertical line, it's only hitting once. This one failed right there because it hit everything. That hit twice. That hit twice. B. Here we go. A, B. We'll try not to let you forget anything that we do this year. You have a paper from yesterday. I don't think we got quite finished up at the end of the class break. Remember you were graphing points? It was on that little bitty graph paper that was kind of hard to see.
Yeah.
I just want to finalize state a couple of things. We're not going to do a whole lot more with that particular paper. We're going to have to do a few more of those. It was graphing. It had a half and half on the same side, which shrunk it down so much that made it tough. I don't think so, Hannah. No, that was... That one, pull that one. Yeah, so then you put each of the 4 vertices here, and then you evaluate them by.
Great graph.
Okay, as long as you understand that.
That's do the efficiency
But,
one.
yeah. It's just because it went up to 0.15 from 0.2.
So I don't know, let's go, maybe we should, let's go to number 5, and let's just finish up and do it the best we can with that little tiny, you'll see why that was going to be tough to get done, with 5, and see if we can make use of some graph paper up here. So I'll just be using this first quadrant. For the x's, what's the biggest x we need to get to? 50. So look at your available boxes that you have. And do you want to count by ones to get to 50? What do you want to count by? Did anybody do something that worked out pretty well? 10. By 10, so every box was a 10, or you did every other was a 10, it looked like. Every other has a 10. Okay, I'm going to try to imitate you. So every other has a 10, 20, is this what you mean? 30, 40, 50. The idea is kind of to spread it out. You don't want everything all crammed at the beginning. How about your y's? Where do we got to get to? 0.15. I don't think this will fit. That if we went 0.01, I think you run out of room. 0.02. See if you can get to 0.15. I think you run out of room. Count that off real quick for me. Do you have enough graph paper to get to 0.15? Or do you run out? That's what I was thinking. I wasn't sure because that was yesterday. So if we can't count by 0.01, I guess the next best thing, let's count by 0.02s maybe, see if that'll fit. Let's go 0.02, next line 0.04, 0.06, 0.08. After 0.08, got to keep them the same, got to go up by 2. So 2, 4, 6, 8, 10. So 0.08, 0.10, how about 0.12, 0.14, 0.16, and wouldn't 0.15 fit somewhere in between there? Now would you try to go graph your points? Now go try to graph what you can, like that. And it gets kind of tedious out there to the right.
unfortunately, when you get into a blue collar area, people don't quite grasp the importance of education the same way. I'm not telling you anything you don't already know, right?
Just deep. So I'm gonna try to graph 0.15, and I'm gonna try to graph 20.03, and I'll go 30.01. Okay, take it 40, not much, I'm trying to, 50, oh, I missed my 40 mark. Part B, it is certainly inverse. Watch the inverse part of this. You know, as you saw these going this way, remember inverse as one gets bigger, the other gets smaller, that idea? Look at my x's get bigger, what are those y's doing? Next to nothing, aren't they? As the x's get bigger, the y's are next to nothing. Then we're supposed to find the answer to something. Well, our equation would either be k over x or k over x squared. It's hard to tell which branch this turns out to be. Using your graph, what would the resistance be if the current were 75 amps? 50, 60, 75. My goodness. Like, just make up an answer. What do you think it's going to be? It's not going to get there. Remember that whole word of asymptote? That it approaches 0, but it's never going to cross over the 0. So, oh yeah, definitely less than 0.1. I mean, like, it might be something crazy like this. It won't get to 0, because it never gets there. That's that whole idea of an asymptote. And I just thought this was a good example to talk about that meaning of an asymptote. If that's happening at 75, my gosh, what might be happening at 100? It won't get to 0. And I'm just making these up, but just to show you the importance.
99.
You know, maybe that's what's happening at 100. It won't get quite to 0, and it won't ever cross over the 0. But that's where it's truly, truly headed. Alrighty, somewhere. That's not right. There we are. Wrong shelf. Wrong shelf. Let's go deliver some pizza. It used to be the case, Domino's used to run this promotion, that if you called to have a pizza delivered, if they didn't get it to you in 30 minutes or less, if there's any quality, get it, 30 minutes or less, that I think at one point it was free, and then I think it cost $3 after that. They changed their policy a little bit. I don't know what they do now. So, you're on the one that, make sure you're on the pizza graph. That's that little tiny graph paper, but you'll be able to fit it. So you're on the little tiny, tiny, tiny graph paper. And here's how fast, you got some rates. You got the pizza drivers, whether they're going 4 miles per hour or 120 miles per hour. So that might be kind of fun to see what's happening. And there's the time that it takes them to get their pizzas delivered. That's in minutes. So there's your table. And it's always, I don't know why the destination is 36 miles from the restaurant, but we're always going to go 36 miles. So we're just going to kind of mess with this a little bit. If our pizza driver goes 4 miles per hour, it takes them 540 minutes. And then we're just going to have him keep driving faster and faster and faster. And I want you to graph his rate and those minutes to get there on that graph below. And then answer some questions. So, your rate, down at the bottom, you just use rate along your x-axis. You need to get to 120. So find a good scale that'll spread it out as much as you can. That's what you're going to count by, so you can get out to 120. And you got to count, you know, by the same thing each time. You can't go 2, 5, 20. You gotta count by 2s or 5s or 10s or 1s. Find yourself a good way to scale that out there. And then when you're ready to go up the y-axis, find the highest one and scale your y-axis so you can get up to the fastest.
540.
Or I guess that's time, never mind. I'm at 540, wow. Faster than NASCAR. Fastest for, that's the down on the x-axis, 120. Once you got your paper scaled, you could just start grabbing. You can just keep right on going, finish her up. Oh, I see, to see how many to count by. And then it gets to be, yeah, it gets kind of tough to count off by that, yeah. You're hoping for something like 50, 100, 150. That's a great idea, the plan, though, if you were really truly maximizing it, that is exactly what you would do. But when it's just something that's just like a math paper worksheet, it doesn't seem like it's really bother to think that hard on it. That first one, 540 minutes. That's 9 hours. What would you think if they said, yeah, I'll be there in 9 hours? Well, that's true. Yeah, can you leave now? We gotta order it on my way, when I leave for work in the morning, I'm gonna order that pizza so that it'll be there. I don't know what we would be doing if we can only go 5 miles an hour. A bicycle, I go faster than that. Yeah, that's not too far off a walking speed. Yeah, it better be one of those heavy duty insulated carriers.
You want us to keep going on A, B, C, D?
I do, yes, please.
Do this as ordered pairs. Go ahead and draw what you think that curve would be like on those. Take your fingers through that. Make it easier. There it is, huh? Okay. You sure put a lot of work into it. Yeah, no, not that line. So you're going to put 7. 7 to the 11. 12, so we'll pass it down to the 98. 15, 44. 18, 20. But don't be thinking so hard, we'll just get them estimated on there.
It's not in
What's that?
this list. Can't find it if it is. 2-1, 2-2, 3, 2-9.
Might just have call series.
Yeah, whatever, right here.
What is that for?
Sure, it is right in there. Oh, no, no, over here, right here.
Are we ready to answer some of those questions on the bottom? Yep, we can. So what'd you say for A? Direct or inverse?
Inverse.
What?
Inverse.
Inverse. Does that make sense? Faster the pizza guy drives, the less time it takes to get there. Not counting any other unforeseen circumstances that happen along the way. B, what type of graph fits up above? Do you remember the name? Hyperbola? Or the other one, remember, it's that whole first quadrant. We don't know right now if this is in the other quadrant, which makes it a hyperbola, or we don't know if that was going on. So we don't really know. But it's one of the two. It's maybe a hyperbola. At least that one has a name. C, write a variation equation. What's the equation for that hyperbola? Y equals K over X. Alright, I'm going to raise this board. Let's use the chalkboard for a minute. If it's Y equals K over X, go up to your data, pick any one of them.
4.
You want to use the 4? Alright. If we use the 4, is that a, I don't know what K is. Is the 4 a Y or an X? It's an X, and what's the Y? So, supposedly 540 equals K over 4. Solve for K. $21.60. Now, if this really is a hyperbola, go to another piece of data. Don't care which one. Pick another one.
35.
35? All right then. And let's go back to Y equals K over X. And is the 35 the Y or the X? The X. And so it had a 62 with it, didn't it? So it says 62 equals K over 35. But this is the same problem. So what's K supposed to be? What's K? 2160. How close do you get?
10.
Is 2160 divided by 35 equal to 62?
60.7.
It is 60 point something?
61.7.
Okay, that's pretty close then, don't you think? I think that's pretty close. Let's check another one.
But when you plug it into the calculator, 62 equals K over 35, and you multiply 62 and 35, you get 2170.
Okay, that's okay. Meaning, and I know it's not exactly the same, but that's pretty close. You know, so we're just saying, like, for realistic data, you know, we had to stop for a stop sign, we had to outrun the sheriff, you know, whatever the case might be. You know, so we got a few little differences, but they ought to be close. Let's go pick another one. Pick one far out on the end.
7.
Which one?
120.
120, all right. So let's see, 120. So let's go back to Y equals K over X, and we're going to put a 120 in for X and an 18 for Y. Does that work? Does 18 equal, either way you do it, just see if they're close, 2160 over 120. Or go the other way. Are they about close?
Yeah.
2160.
Okay, yeah. So that must have been the right equation. Remember we wondered if it would be Y? We wondered between here or here over the X squared one. And if these numbers would have been terribly off everywhere, maybe we would have said, you know what, I don't think it's that one, we better go with that one. But sounds like it would be that one. And that's what we were doing the bottom one. That's really pretty much, we should answer that though, using either your graph or your calculator, if you want to use your equation. Approximate time it would take the pizza to be delivered if the driver drove at 32.5. Use your graph. If you go 32.5 miles an hour, what do you think? Because I did it mathematically. Look at your graph. Let's just see how close we are. If you go 32.5 miles an hour, you said what? About an hour. Mathematically, it came out to be, I think, something like 66.5 minutes, which is about an hour, wouldn't you say? All right, so we must have found the right equation. Let's flip it over to the other side. Do it one more time, and that's all we have to do. So you get to graph and answer some questions one last time, and then we are done for the week.
Did you knit that?
No, my mom crocheted this.
Or crochet?
My mom knitted it. It's called arm knitting.
My daughter has done that. I have one just almost the same color that looks like that.
I have a blanket my great grandma gave me. That was crocheted. Just don't see much crocheting.
My mom can crochet anything. Steve Ditch makes it. The knit pattern, Steve Ditch makes it. And that's what she does. For hours and hours and hours, I do it.
They did.
Well, said, but I can't crochet.
It would get you all the way to
I can't crochet or
625
sew.
though.
My mom can't, she just
So it
started
doesn't
it.
really like.
My mom can't I'm fitting so weird.
What?
We can be all the way to 10. She literally looked at the
I mean,
speed and
yeah,
my
but
mom was
it's still gonna get you like pretty high speed graph. It's gonna be
Really
direct.
crocheting.
I'm one of those people who rides up and clear for the end, and I'll keep sewing the backs together.
So we just start from here then.
So there's nothing left.
Basically, or, I got prototype rope, I got prototype worms, worms.
Yeah.
You're supposed to put it into a fishnet.
Some of these
Yeah, it
direct
doesn't matter.
the same way, inverse, they're kind of where, here, 5 times 2 is 10, 5 times 4 is 20, 5 times 6 is 30.
How old are your
Does that
children?
make sense? So, on these, and the reason these T varies between equals, and then always put your constant in front of that. Direct will tell you whether or not it's going to be a multiplication. Inverse will tell you that it's going to be a division, right? And then you miss the cube. Cube in that one, square in that. So just kind of get to that point where you're getting to that varies and think equals from there. Because the first part is one where to plug in, right? This is always the kind of the telltale. That tells me exactly what style. When you do multiplication, right, is the generic one, or division is the generic one. Okay. Still got the B's something in there, so.
I equals K squared, right?
Here's where it says radian is very equation.
That means like y equals kx squared.
You really do.
Kind of hard to hear.
You don't speak long enough.
What I did, I did with the yeah, you can do that.
Do we have a graph to work with? Everybody's got a graph? This might be a little lower. Some graphs can do that definitely.